Okay, well, thank you very much. Well, in 1842, the British scientist Richard Owen realised that 3 recently discovered fossil reptiles possessed a set of features that weren't present in any other reptiles, most notably a massively reinforced hip region where an unusually high number of vertebrae helped conduct weight from the pillar-like limbs to the giant body. He regarded these animals as land-living reptiles that were kind of similar in basic structure to elephants and rhinos. And of course, he termed them dinosaurs, and their name means fearfully great reptiles. But it wasn't until the 1870s that discoveries made across Europe and North America revealed the true body shapes of the different dinosaur groups. The bipedal predatory theropods, the quadrupedal horned and armoured ceratopsians, ankylosaurs and stegosaurs, the ornithopods like iguanodon and the so-called double-billed dinosaurs, and the gigantic long-necked sauropods. Now, there was a time that extended from about 1910 until the 1960s in which dinosaurs were rebranded as failures, as animals that were badly designed overall. They couldn't run, couldn't jump, they couldn't... oh my God, sorry. In the case of herbivores, they couldn't deal with plant material. They were regarded as like this weird ragtag group of unrelated animals, and they were regarded as inferior to mammals and birds in physiology, mechanics, and structure. And an idea really popular at this time was that dinosaurs of several groups were aquatic, that they spent their time wallowing, floating, and feeding in water. Supposedly the world was covered in giant lakes and swamps. Supposedly temperatures worldwide were perpetually, eternally tropical. And that, of course, brings us to why we're here today. As you have heard, Brian Ford has argued in popular magazine articles, in talks, and in a book that you've now seen, that dinosaurs of basically all kinds were aquatic, and he's thereby revived this view that was popular more than 60 years ago. Today actually marks the 4th occasion in which I've argued against Brian's aquatic dinosaur model. The first occasion was in 2012, when I was invited to produce a published response to Brian's laboratory news article. There's a link to my article on my Twitter feed at the moment. The second occasion was in 2015, when I blogged about Brian's model after seeing him give a lecture. The third occasion was for an as yet unfinished TV show. Why do I do this? Is it to build my own fame and notoriety? Yes. No, no, it's not. It's because I feel quite strongly about the spreading of misinformation, and I seek to set the record straight when said misinformation overlaps my own area of expertise. And this isn't exactly a one-off. I have engaged on many previous occasions with people who promote what we can charitably call non-standard views. Brian appears to be somewhat surprised by the rejection that his model has received from paleontologists. Now, the primary reason for this rejection is that paleontologists are familiar with a large quantity of data that absolutely contradicts Brian's model, but what's encouraged a lack of interest in challenging or contesting Brian's model is we've been through all of this before. The claim that dinosaurs were aquatic is old and familiar. It was tested and thoroughly, refuted in previous decades. I'm afraid this isn't a new science of dinosaurs. It is quite an old, tired, discredited science of dinosaurs. So during the late 1960s and early 70s, the American paleontologists John Ostrom and Robert Bakker argued that dinosaurs were social animals, that they had bodies, organs, and sensory abilities about as sophisticated as those of mammals, that dinosaurs likely had an elevated metabolism, and that dinosaurs didn't become extinct. Dinosaurs live on as birds. Birds are dinosaurs. And this overturning of ideas, this paradigm shift, is known as the dinosaur renaissance. And one of the first issues tackled in the dinosaur renaissance was this mid-20th century aquatic dinosaur idea. In 1964, Ostrom analysed evidence relevant to the lifestyle of the so-called duck-billed dinosaurs or hadrosaurs. He showed that they were terrestrial, that they lacked any features associated with a lifestyle that involved wallowing and floating and swimming and such. I keep on referring to these particular dinosaurs as so-called duck-billed dinosaurs, and that's because this term is a complete misnomer. Fossils with soft tissues intact show that they weren't duck-billed at all. Instead, they had this massive downturned horny bill, and both stomach contents and fossil gums show that they used this massive downturned bill to break off conifer needles, twigs, and bark, which they chewed up with the massive tooth batteries in the back of the jaws. What about the other studies that overturned the aquatic paradigm? Well, in 1971, Bakker published Ecology of the Brontosaurs in the august journal Nature, and he showed how the bodies and limbs of sauropods and the rocks in which their fossils are found demonstrate terrestrial habits. A more detailed 1975 study by Walter Coombs made an even stronger case for terrestrial life in sauropods, and everything we've discovered since has backed up this view. Now let's kind of step back a bit and ask the fundamental question that's at stake here, and this is, how do we determine the lifestyle of a long extinct animal? Well, we basically never have as much evidence as we might like, but we do nonetheless have a huge quantity of evidence pertaining to anatomy, functional morphology and biomechanics, bone microstructure, geology, tooth wear, trace fossils, associated flora and fauna, and isotope geochemistry. And as scientists, it's our duty to look at all of this evidence, not just to cherry pick one or two things and ignore everything else. And the data we have shows that sauropods, theropods, hadrosaurs, stegosaurs, ceratopsians, and so on, they were terrestrial animals. Let's take Tyrannosaurus as a brief case study. Brian has argued that this was an aquatic animal and that it lived something like a giant crocodile. What does anatomy, functional morphology, and biomechanics say? It says no to this idea because there are numerous features of anatomy and structure linked to a committed terrestrial life. What does geology say? It says that Tyrannosaurus was an animal of woodlands and forests, lacking any special association with the sandstones that were deposited in local lakes and rivers. What do trace fossils say? What does associated flora and fauna say? What does isotope geochemistry say? Tooth marks show that Tyrannosaurus killed and consumed terrestrial animals. Its tracks and droppings are found in terrestrial environments. Its fossils are found alongside those of terrestrial plants and animals. Isotope geochemistry showed it lived and fed and died in terrestrial environments. A trustworthy principle that we apply when trying to work out the lifestyle of an extinct animal is form-function correlation. The idea that you can make inferences about the lifestyle from form, from anatomy. So aquatic vertebrates are streamlined. They have bodies, limbs and tails that are clearly specialised for life in water. They have a weak, reduced or absent sacrum. That's the region connecting the hips and the spine. They tend to be long-bodied with small, reduced or absent limb girdles. Their bones have thickened walls, reduced marrow cavities, an increased porosity or an increased mineral content. Now, of course, many aquatic animals are quite capable of walking around on land. Think of, for example, newts, crocodiles, ducks, water voles, hippos, and so on. But these animals still have features linked to their aquatic specialisation. They have those weird bones I just talked about. They tend to have long spreading digits. They typically have extensive digital webbing. Look at the crocodile foot at top left there. They have loads of features of the head, body, tail and limbs linked to a swimming, wading or diving habit. Non-bird dinosaurs were not like this at all. They don't have any of this stuff. Non-bird dinosaurs are not streamlined. They often possess serrated skin frills, nodules or spines on their bodies. I'm not even going to talk about feathers and filaments in this talk today. They have their nostrils, eyes and ears are not located up on the top of the head. Their limbs are column-like and clearly specialised for terrestrial life. In fact, sauropods and hadrosaurs have got these small, columnar, sort of hoof-like hands. Theropods, predatory dinosaurs, do at least have long spreading toes, suggesting in theory an ability to move on soft ground, but tracks show that they certainly didn't have any webbing. Do we see limb joints, limb girdles, and a sacrum consistent with aquatic life in these dinosaurs? No, we see robust limb joints, enormous limb girdles, reinforced hips, enlarged, broadened, lengthened sacral regions. Sauropods and non-bird theropods were highly pneumatic animals. What I mean by this is that a system of air-filled sacs connected by tubes to the lungs were present throughout the body cavity and also throughout some or much of the skeleton, including on the ventral cells, including on the underside of the body. And this is absolutely relevant because if you're aquatic, you don't want to be pneumatic. The more air you contain, the more buoyant and unstable in water you are. Indeed, sauropods are such an unusual shape and are so pneumatic that they would be unstable and prone to tipping were they to go into deeper water. Now, after I wrote about it in my laboratory news article, Brian has, on a couple of occasions, referred to this study by Donald Henson and kind of dismissed it, implying that the results are arbitrary and basically down to supposition, hand-drawn supposition. And I don't think that's at all fair. In fact, if you look at the studies, what Henson actually did is use 3D density calculations to work out where the centre of mass and centre of buoyancy are only after a list of parameters are in place. Those parameters include overall tissue density, the size, shape and position of the lungs, the size, shape and position of various other air cavities within the body. Furthermore, this technique has been extensively ground truthed on a wide variety of living animals, including turtles, alligators, elephants and horses, where the results are reliable. This modelling work shows that when placed in water, giant pneumatic dinosaurs were too buoyant and too unstable to be proficient in aquatic conditions. They certainly can't be said to be adapted for aquatic conditions. Note that swimming, wading and diving birds have a substantially reduced amount of pneumaticity relative to terrestrial birds, and furthermore, the modern birds that are most like sauropods and non-bird theropods as goes pneumaticity are big terrestrial birds like ostriches and bustards. When it comes to form-function correlation, a huge quantity of evidence confirms a terrestrial lifestyle for the vast majority of non-bird dinosaurs. That's not even a complete list. There's a huge amount of evidence here. Now, I say the vast majority of non-bird dinosaurs because at least some non-bird dinosaurs likely were aquatic, or at least semi-aquatic. I don't have a problem with that idea. This is Spinosaurus. It's a giant sail-backed Cretaceous theropod from northern Africa. And in 2014, Nizar Ibrahim and colleagues argued that it was short-legged, long-bodied, with small limb girdles, spreading toes, broad flattened toe claws, thickened vocals, reduced marrow cavities, crocodile-like snout, retracted nostrils, and crocodile-like teeth. A list of features that led them to interpret it as an aquatic dinosaur. Previously, we had been good scientists and we had thought that these were wading animals that maybe behaved something like giant herons. So this was quite a radical reimagining. Ibrahim et al.'s paper is still controversial, but, and there's complicated reasons, but I don't have time to discuss them, but the evidence for aquatic habits in Spinosaurus is reasonably good. Now, cast your mind back to what I said a minute ago about form-function correlation. Ibrahim et al. Suggested aquatic habits in Spinosaurus because they identified relevant anatomical specializations. So if we're going to suggest aquatic habits in a dinosaur, we have to do so on the basis of fairly compelling anatomical arguments, not just on assertion. This is Halsteraptor. It's a duck-sized Asian theropod. It was described last year by Andrea Cow and colleagues. And like Spinosaurus, this animal has a long list of features indicating that it was another aquatic dinosaur. There are various other non-bird dinosaurs that have been suggested to be swimmers or waders, although it has to be said that a lot of these cases are actually pretty dodgy, but some non-bird dinosaurs were probably aquatic. And I should add that non-bird dinosaurs of many kinds were almost certainly good swimmers or waders, as are many living terrestrial animals. But to make some blanket assertion that dinosaurs as a whole were aquatic, it runs contrary to this vast amount of evidence, and it lacks any interesting support. We need to return briefly to Spinosaurus. We need to talk about that sail. The sail of Spinosaurus is supported by long rectangular outgrowths of the vertebrae, structures called neural spines. Spinosaurus is not unique in having these dorsal sail. The dorsal sail actually evolved several times in various different dinosaur lineages. And Brian has sometimes compared the sales of these dinosaurs to those of fishes, like lancet fishes and sailfishes, the implication being that sails are linked with aquatic habits. But the sails on the fishes are nothing like the sails on the dinosaurs at all. The sails on the fishes are supported by flexible rod-like rays, not by big, robust processes that go out of the vertebrae. And furthermore, the sails in these fishes are hypermobile. The entire sail can be folded down. In contrast, the sails on the dinosaurs are far more similar to the sails on living terrestrial reptiles. There are a whole bunch of modern chameleons that have tall rectangular neural spines and dorsal sails very much like those of these dinosaurs. In the chameleons, the sails are used as sexual and social signalers. So the claim that sails have something to do with aquatic habits, it is not true. Now, is there an implication in Brian's law that dinosaurs, some dinosaurs were so big and so heavy that they couldn't support their weight on land? I mean, you certainly do get that impression from the title of the book. We know that many sauropods exceeded 10 tons. We have good remains of species that must have weighed around 80 tons. And there's even track weight evidence showing that some species must have been over 100 tons. That image shows a single dorsal vertebra from one of these giants. Well, a list of biomechanical studies, most notably those by late great Neil Alexander, show that the bones, muscles and cartilage pads of even the biggest sauropods were absolutely capable of bearing their weight on land. Work on bone strength, the safety factors involved, the stresses involved in bending, the muscular strength required to move the bones, the strength of cartilage pads and so on. All that work has been done. The conclusions, even the biggest dinosaurs were capable and even athletic on land. Go and check Neil Alexander's excellent and highly readable book, Dynamics of Dinosaurs, if you're interested in taking this further. Brian, when you showed that video of the Komodo dragon, I'd like to know that Komodo dragon had chronic arthritis in its limbs, although that's a moot point because you didn't use it today, so I apologise. What about that tail? Brian says that the dinosaur tail is a problem for a terrestrial lifestyle, that it's too heavy, too costly for a life on land. Well, again, this is absolutely contradicted by abundant evidence. And there are three main points I need to cover here. First point, articulated skeletons do show that the tails of dinosaurs were indeed held horizontally, they were held well off the ground. Complex interlocking bony joints, ligaments, and constantly firing, non-tiring, so-called postural muscles were all involved in keeping the tail aloft at low metabolic cost. All three of those things are standard bits of kit when it comes to skeletal support in land-living vertebrates. You have all three of them functioning in your neck right now. The presence of these anatomical features falsifies the claim, that the assertion that horizontal tails pose some kind of energetic problem for terrestrial animals. No, they don't. The second point, what was the function of the tail? Well, it wasn't just a dead weight, nor do we think that its primary function was the counterbalancing of the rest of the animal. And we can say this because the longest necked and heaviest headed dinosaurs are the ones with the shortest, proportionally the shortest tails. Instead, the tail's primary function is to anchor the biggest, heaviest, longest muscle in the reptile body. It's called the caudofemoralis longus, or CFL. This is the giant muscle that pulls the leg backwards during walking. And having a gigantic muscular tail that anchors an enormous CFL is the default condition for terrestrial reptiles. This might seem weird to you because you are a weird giant bipedal monkey with a very different muscle system. You don't have this tail-based muscle system. Some dinosaur groups did actually make the transition from a tail-based muscle system to a hip-based one. This was an evolutionary move that then allowed them to reduce the size of the tail. Finally, the third point on tails, this actually segs back to something I said earlier. Aquatic animals that use their tails for swimming have tails specialised for swimming. The tail is paddle-like. It's either compressed in the up-down or side-to-side direction. It's broadened or widened or flattened in its end part. And with a handful of exceptions, Halscarata is one, dinosaur tails were not like this. I haven't spoken about geology. Brian's model requires, as you've just heard, these dinosaurs were living in lakes, swamps and rivers. And this is an assertion that, I'm sorry, basically requires the dismissal of the entirety of geology, something I have seen done somewhere else before. In fact, decades of work done on sedimentology, stratigraphy, lithology, petrology has established convincingly that the sediments concerned do come from parkland-style woodlands, forests, floodplains, semi-deserts and deserts. You can't just dismiss this. It's not okay to do that. That is the sort of thing that creationists do when they want to endorse their idea of a global flood. I haven't discussed the global setting of dinosaur evolution. Brian tells us that dinosaurs evolved in water, that they were associated with warm aquatic conditions throughout the whole of their history. Now, excluding birds, dinosaurs were around for over 160 million years, and across this period of time, things changed so much that it's impossible to generalise, as goes temperature, habitat, rainfall, and so on. Some non-bird dinosaurs do come from warm or wet places, places where there were giant swamps, lakes, and rivers, places where water temperature was really high. But there are just as many dinosaurs that come from dry, arid, cool, even cold places, places where swamps, lakes, and rivers were rare or even absent. The traditional idea that the Mesozoic was some kind of perpetual eternal hothouse where both air and water temperatures were constantly over 30 degrees C is absolutely contradicted by numerous studies. The overall pattern of dinosaur history is the story of land-living animals that were living in variable, sometimes temperate conditions. It's not the story of sloshing around in warm water animals that were living in some eternal hothouse. I haven't discussed ecology, so work on tooth shape, snap shape, tooth micro, macro, leg length, neck posture, and so on shows that herbivorous dinosaurs were terrestrial browsers, feeding at different heights on various different plant groups. Meanwhile, the predatory theropods have skull and tooth configurations that are clearly adapted for terrestrial predation. They are not at all similar to the configurations we see in aquatic predators. I haven't discussed trace fossils. Millions of dinosaur footprints are known. These tracks, made by feet, clearly specialised for terrestrial life, they are associated with desiccation cracks, raindrop impressions. The majority of these millions of tracks were made by animals walking on land, not by animals walking through water. There are some rare purported swimming dinosaur tracks. As I said earlier, I'm sure that dinosaurs of many kinds waded or swam on occasion, no problem. But all of these so-called swimming dinosaur tracks are controversial because many of them have turned out to be partial tracks, under tracks, or even tracks made by non-dinosaurs, like turtles, excuse me. I've mentioned oxygen isotopes a couple of times. The tissues of living things incorporate oxygen isotopes according to environment, and it's now well established that the tissues of aquatic animals have proportionally low quantities of oxygen 18 relative to terrestrial animals, as you can see on that graph. The isotope ratios in the bone phosphate of dinosaurs has now been analysed many times, and the results show for many species from many places, these animals have terrestrial isotopic signatures, the exception being Spinosaurs, which do have an aquatic isotopic signature. So, to wrap up, Brian has claimed that non-bird dinosaurs require reappraisal, that our view of them as terrestrial is wrong, and that we should resurrect a really quite old view of them that was otherwise stone dead. But aquatic animals possess a suite of distinctive features, and with the exception of a few weirdos, Spinosaurus, Housecaraptor, etc., these features are absent in non-bird dinosaurs. Indeed, form-function correlation shows that non-bird dinosaurs were, again with a handful of exceptions, they were terrestrial. Their limbs, hands and feet, reinforced hip regions, bone microstructure, extensive skeletal pneumaticity, the positions of their eyes, ears and nostrils, and so on and on shows they were terrestrial. Hadrosaurs were not duck-billed. The sailor Spinosaurus is not like that of a fish. The dinosaur tail is not some super expensive maladaptive dead weight, but instead an adaptation to terrestrial movement. And again, with one or two exceptions, the dinosaur tail is not of the form suited for swimming. Empirical studies of bone and cartilage strength show that dinosaurs function within the safety parameters of these materials. There's no reason to imply that dinosaurs pose a biomechanical conundrum. Geological data links non-bone dinosaurs with terrestrial environments. Dinosaur tracks were overwhelmingly formed in terrestrial conditions, and isotope geochemistry ties these animals to terrestrial environments. I want to end this talk by moving slightly away from dinosaurs and reminding you of the entire angle of attack that Brian has favoured in his promotion of this aquatic dinosaur model. And because as we've heard today, Brian has framed this discussion as one in which a blinkered, biased paleontological community has such a vested interest in maintaining the status quo, such an inability to consider the wisdom of an outsider. They've closed ranks and refused to listen to his brilliant idea. And this makes for a really appealing story. This is the myth of the lone truther, and it's made Brian a very popular speaker to many audiences. Including this one. It works well when your audience, the present company accepted, it works well when your audience is not composed of dinosaur experts, or indeed is not composed of people who understand the scientific process itself. So this is a completely unrealistic interpretation of what's happened. The people who criticised Brian's aquatic dinosaur model aren't ivory-towered fat cats feeding from some imaginary bottomless drop of grant money, desperately clinging to a tired orthodoxy and too arrogant to turn about face. I don't know, anyway. No, the people who actually criticised Brian's dinosaur model, and it's easy to find this out if you look into it, are mostly journalists, science writers, and independent researchers. So in other words, the exact same people who have the most to gain when weird left-field ideas and paradigm shifts come to the fore. The claim that Brian has been shut down, has been denied the right to speak, that he was petitioned against, I know that happened, weird and pointless, but this claim that's been shut down is disproven by his phenomenal success in promoting this idea in articles, in talks, a book by HarperCollins, and a vast amount of coverage in the media. If you look at scientific ideas on dinosaurs published over the last few decades, it's obvious that paleontologists have been the opposite of dogmatic, inflexible, and unchanging. On the contrary, we've had to constantly change and revise the stuff we said in the past. And the idea that we have some special emotional attachment to what Brian has called terrestrial hysteria is dishonest, it's underhanded, and it's, I hate to say it, but it seems anti-scientific. It ignores the actual reason for our confidence in the terrestrial model. This reason being that we followed a huge quantity of supporting evidence. In other words, we've behaved like good honest scientists. So has Brian's model been contested and rejected due to an intolerant, conspiratorial community, or is it just that he is wrong? Thank you.